So, hello everyone. My name is Vaibhav and I am from New University from IT department, School of Technology. Okay. So here we are discussing what is Simpson rule. So first of all, we have to what is Simpson rule. So Simpson rule is one of the numerical technique, or we can say method, used to approximate definite integrals. It will give the more accurate approximation than the trapezoidal rule, and by finding parabolas through the segment of curves. So this is the definition of Simpson rule, and here I am writing the formula. So the formula is, I have taken the function as a general function. So my intervals are a, b, and the function is f of x. So according to the Simpson rule, the integration of this whole function, the antiderivative in this rule, we are not knowing the what is the antiderivative of it. So we are finding the most accurate value. Okay. So the according to the formula, we have to do h upon 3, this h upon 3 a to b f of x dx is equal to h upon 3 y naught plus yn plus 4 into y of 1 plus y of 3 plus y of 2n minus 1 up to this plus 2 into y of 2 plus of 4 plus up to y of 2n minus 2. This is the formula. We can write this formula as in general terms as the function a to b f of x dx is equal to h upon 3 into the sum of extremes plus 4 into sum of odds plus 2 into sum of even. This is the general formula. We can also write this as h upon 3 into y of y naught plus yn plus 4 into sum of n is equal to I is equal to 1 to n minus 1 to n minus 1. I'll take it as a general, and the gap is 2 y of I plus 2 into y of k is equal to 2 to 2n minus 2. I'll take gap is 2. Actually here we are calculating the sum of even terms, and here we are calculating the sum of odd terms. So this one is for odd and this one is for even. Okay, this is the most generalized formula, and as we know that the Simpson rule is one of the most accurate, will give one of the most accurate answer as compared to the trapezoidal rule. So this is the formula. Now we will learn this by taking a example. So this example I have taken. Actually I forgot how to calculate the value of h. So by how to calculate the value of h, there is a one more formula, like n into h is equal to b minus a, like upper limit minus lower limit is equal to n into h. N is number of subintervals and h is the gap. Okay, so we are dividing the whole interval into some part of, like we are dividing the whole interval into small spaces. Okay, if I am taking this line segment from 1 to 2, so I'm dividing the, let's take n is equal to 3. Now I'm dividing this interval, whole interval, into 3 parts, like 1 2 3. This one is first part, this one second, this one is third. So the formula for the h is b minus a divided by n. So here b is upper limit, a is lower limit, and s is the number of sub intervals. Okay, so I'll write it sub intervals. B is upper limit and a is lower limit. Okay, so now we will calculate the, evaluate this function, calculate the approximate integral value, definite integral value for this function. So what we have in our hand, first we need to calculate what is upper limit. Okay, so what upper limit means, b is equal to 6, and what is lower limit, a is equal to 0. Okay, now our function f of x function is x square. Okay, now function is f of x. Now what we have in our hand, we have to calculate what, in how many intervals we are dividing the curve. So we have to take the value of n is equal to 6. Here in the question they have mentioned, so n is equal to 6. Now our solution is, now first we have to calculate the value of h. Now what's the formula for h? H is equal to b minus a divided by n, right? Now what's the value of b? 6. What's the value of a? 0. What's the value of n? Is 6. So the answer would be 6 divided by 6, it could be 1. So the value of h should be 1, right? Now we have to calculate, or we have to make the table. Okay, we have to make the table. What are the values of function at x of 1? We have to calculate the y of 0. Y of 0 means function of value at 0. Value of function at x is equal to 1. Value of function at, this is value of function at x is equal to extreme. Okay, so now we are making the table. Here we have taken I, here I have taken xi, here I have taken a function value I. Okay, so value at 0, so x naught. Okay, function of x naught is equal to, what are the value at x is equal to 0? 0 means x I have to put 0 here, because the function is f of x. Now second function is f of x plus h. The third function is f of x plus 2h. Fourth function is f of 3h. So it could be like this. The function is f of 0h, the function of x. So put the value x is equal to lower limit 0. Okay, x naught means 0. 0 square is, it could be 0. Second one, x1. Okay, now x1, what is the value of x? A function of x is x1 is equal to, now 0 plus 1, it could be 1. The function of x plus h is equal to 1. Now put the value of 1 in this function, and we have got 1 square is equal to 1, right? Now we'll continue this program. X3, x function of 2, this could be square of 2 is equal to 4. 3, x of 4, function of x3 is equal to 3 square is equal to 9. 4, x of 5, function of x5, it could be square of 4 is equal to 16. Okay, now 5 x of 6 function of f of 6 0 1 2 3 4. It could be 4, it could be 5. Function of 5 square is equal to 5, and here I am writing 6 x of 6. It is also like 1 2 3 4 5. Here is 6. Function of f of 6 is equal to 6 square is equal to 0. 6 square is equal to 36, sorry. Okay, so we have got the y0 which is 0, y1 which is 1, y2 which is 4, y3 which is 9, y5 which is 16, y5 which is 25, and y6 which is 36. Okay, now apply the formula. Applying the Simson formula. What's the formula? Function of 0 to 6 x square dx is equal to h upon 3 into y0 plus yn plus 2 into y of even plus 4 into y of odds. Right, this is the formula. Now put the values and get the answer. Here the value of h is equal to 1 3 y0 of 0, like it is 0 plus y0 of n. What our value of n here is 6, right? So y0 of 6, what is it? Is it 36? Sum of extremes plus 4 into sum of odds. So odd is 1, this, and this. These are our odds. So we'll write 1 plus 9 plus 25 plus 2 into sum of even. This one is our even and this one is our even. This one is also our even, but it is included in the extremes. After this there is no value, because our interval which have taken only 6 interval, like we have divided the whole interval into 6 parts: first, second, third and fourth, fifth and sixth, right? So we will only consider these two sum of odds. Okay, 4 plus 60. Now calculate the value. 1 divided by 3 is equal to, here write the function. Here also I have write to function, right? This one is 0, this one is 36 plus the how it is 10 plus 20, 35 into 4 into 35, right? And this one is 2 into is 20 plus 40, 2 into 20. Okay, so our answer should be like 1 by 3 into 36 plus 140 plus 40. Now calculate this. This is 180 plus 30 is equal to 210. 210 plus 6 is equal to 1 by 3 into 216, right? Now this one is also divided by 3. Now what we have got the value 7 into 2, 72. So the value of this function is 72, which we got through Simpson rule. So after applying the Simpson rule, we got the value of 0 to 6 x square dx is equal to 72. Now we will calculate what's the value of a function if we are using the definite integrals, right? Now what is the question? Question is integrate 0 to 6 x square dx. Now calculate the, like, normally what's like how integration will work. So it could be like x cube by 3, 0 to 6 is equal to 6 cube minus 0 cube divided by 3, right? So it could be 216 minus 0 divided by 3. It could be 216 divided by 3. It should be 72. So by the normal value of integration, by applying the normal integration which we are done in class 12th, it is giving 72 value, and after applying the Simpson rule it is also giving the value 76. So we can consider the Simpson rule is one of the best method to calculate the value, or like as compared to the trapezoidal rule. The Simpson rule is more accurate. Okay, this is the one of the key point. Now I will talk about where we can learn application of Simpson rule. This one is 1/3 rule of Simpson. Okay, 1/3 rule. There is 3/8 rule also. 3/8 rule, which we'll cover later. If you like this video, I'll cover it also. But this one is 1/3 rule application. Now I'll talk about the application. Like first application is engineering field. In the master's degree and in the, like, you are like really interested, so this one is the more like useful method. Second is in physics. Third one is computational science, like computer science we can say. And third one is fourth one is also in biological, like in engineering, like in engineering every field. Whether it is data sciences or it is like biotechnology, you use this method. It is more efficient and accurate than trapezoidal rule. So now I'll bring my next screen, which is in my laptop. I'll share the code, a Java code for the Simpson rule, to verify whether we have done this correctly or not. I'll take this example. I'll take this example which I have done here, and I'll show two codes of Java program. First one is which user have to put the input. I'll share it in the description also. And second one is where the user has already put the function, whatever it is, and after putting the function he has to put the upper limit and lower limit and the number of sub interval, which, like, how many intervals he is dividing. Okay, so we'll bring on the next screen. So this one is my Java code for the Simson rule, and here I have used two libraries which I have imported. So these library will evaluate my function, so computer can understand what function which we are putting. This is scanner library. By using this, user will put the input by using it. Okay, now here I have implemented this scanner. Okay, then our first step is we have to evaluate, like user have to put the function, so it should be put like this. Okay, so here you can see this is x raised to power. In other you have to write asterisks like this formula, but no, in Java you have to write like this. Okay, if you are raising some power you have to use this formula, this symbol. Okay, second, user will put the lower limit, then the upper limit, then the number of intervals. Then if the n is not even, then it will raise an error or return. After that, our third step should be like we have to calculate the value of h. I have put the whole formula, and double is a type of a like data type. Okay, so double is the size of double is 8-bit, I think. Yeah, right. Okay, now by using the expression builder library, here we have evaluate the function. Now we have initialized the one sum variable. We have stored the initial value 0. Okay, now here we have initialized the for loop which starts from 0, goes up to n, and increment by 1. The value of x should be like what is where we have put the x is equal to a plus ih. Okay, it will use the x from there. Okay, now we have applied some condition. If our I equal to 0 or equal to n, then it will store the direct value. If not this, then else this. If our I completely divide by 2, then it will store 2 into function of x from here. The function of here should be calculated from here. If both conditions are false, then it will be executed. Means our function like function when the function value is odd, like y of 1, y of 3, y of 5, 7. Okay, when it came out from this loop, then it will multiply the sum variable in this. Now after this, the sum variable have to not equal to 0. It has some value that should be multiplied by h by 3. It will store in this result, and then it will print this is the generalized formula. Here I've used the scanner class. This one is class I have created. This one is method, and this is method which it will return the function. Okay, I have taken this argument x as an argument. Here it will ask first the lower limit, then upper limit, then the interval. Same, like n is not even, then it will raise an error. Then we have calculated the h value, then initialize the sum variable. Here the loop has been started. It will store in the sum, then sum should be multiplied by this, and then the system will give the value. Okay, now you have to like run this code. Okay, run it. Clear, run it. Okay, now we have to put the value of what? A, which is 0. The value of b is 6. The number of interval is 6. The value is 72. Okay, that means that the code which we have implemented here is correct. Actually the value of this function according to the Simson rule is 72, and according to the normal integration is also 72. Okay, so thank you for watching this video. Hope you understand something. If you have any queries, just let me know in the comment section, and I will give you both codes you will run in your program. Actually the second code is also work, but there is some issue with my JDK file, Java development kit. So you can use that code, it will work. You just put the function, okay, and use this code also. Just change the this, okay, you just implement the another function. Okay, so thank you for watching. Hope you understand something. If you have any query, just let me know in the comment section, and I'll make more further videos for the future. Okay, thank you.